Welcome to Study Loop.
Here we are going to explain the octet rule exception by using the Lewis structure. Step 1. The octet rule is the chemical rule which refers that the atom or element tend to combine with other atom in such a way that each atom has 8 electrons in their valence shell to attain the stable noble gas configuration. So the exception of the octet rule is odd electron species, the species which have odd number of electrons incomplete. And for octet species, the species which have less number of 8 electrons. And for the expanded octet, they have more than 8. So now for Pf6 minus that we known as hexafluorophosphate ion, phosphorus has 5 valence electrons. Fluorine has 7. We have 6 fluorines and we need to add these valence electrons up here for a total of 48 valence electrons. So now phosphorus is the least electronegative. We will put that at the center. And then we will put the 6 fluorines around the outside. We will form the chemical bonds between the fluorines. And the phosphorus, each of this is a 2 valence electrons, so we have 6 bonds. We have used 12 valence electrons completing the octet of the fluorines. So we have used all 48 valence electrons in the Pf6 minus Lewis structure. The key here is that phosphorus is below period table 2 in the period table. That means it can have an expanded octet. It can hold more than 8 valence electron. Phosphorus has a formal charge -1. So that's the Lewis structure for Pf6 minus. And now for ClO3 minus, let's do the ClO3 Lewis structure. Chlorine has 7 valence electrons plus 6 for oxygen, and we have 3 for a total of 25 valence electrons plus that -1 makes it 26 valence electrons. The chlorine is the least electronegative that goes in the center and oxygen around it. The two valence electrons to form chemical bonds between the atoms, so we have used all 26 valence electrons and each atom now has an octet. So now by making this octet, it looks pretty good, except chlorine is in period 3 of the periodic table. That means that it can often hold more than 8 valence electrons. So we need to check our formal charges. Turns out our formal charge show that we have a +2 formal charge on the chlorine. So on the chlorine, that on the oxygen each have a -1 formal charge, which makes sense, but the closer the formal charge are the zero, the better the structure is. Let's take a look and see how we can fix this. If I take these valency electrons right here and move them into the center for 2 oxygen, that should take care of this +2 charge. So let's see that does to our formal charge. Now that we have moved this in the center, they form double bond. So by making those double bond between this oxygen and chlorine, this one here, we know a formal charge of 0 on the chlorine. And the one here, we know formal charge of 0 and the chlorine on this 2 oxygen right here, while this oxygen, the black one, has -1 charge. That makes sense because the total charge here is -1. And that makes sense because the total charge here, negative 1, this is a negative 1 as well as one last thing is since it has an ion, so we need to put the brackets around it to show that it has a negative charge. Now, phosphorus acid. So here we have 26 valence electrons for H3PO4, PO3, lower layer structure. So we will put phosphorus at the center and that is least negative. So then we have these three oxygen. Let's put those around here like this. And usually we see that hydrogen in the front that tells us it is an acid and they normally go on the has HS. I also like to put the hydrogens on the outside. When I can, so I am just going to put these hydrogen atoms here on the outside. At this point, we have our skeleton Lewis structure. So we can start putting the electrons between atoms to form chloral chemical bonds. To here that we will complete the octet on this oxygen right here. Now we have only used 24 valence electrons. So we have two more we need to use, but that's great because phosphorus has 6 and we will put the last two here and we are done. This is. So this is a look pretty good layer structure for H3PO4. If you calculate the formal charge, you will find there is 0 for each one of the atoms and that means this is a pretty likely structure for H3PO3. I hope you understand this well. Thank you.